Assalamualaikum warahmatullahi wabarakatuh. Today, we will present our digital project, which is Semiconductor Wafer Production Process. This is our team. First, ASLIZA binti MD.TAHIR, matrix number B0818104992, NURIN FADLHLIN ADLINA binti AWANG TAGHIB, B08181045. Third, NURUL Hasya binti Rojehan, B08181050, and lastly, ZALIKHA binti KAMALUDIN, B0818100075. And this is our agenda. First, introduction, problem statement, proposal, discussion, and conclusion.
Introduction. A semiconductor wafer is a thin slice of semiconductor material used in electronics to make integrated circuits such as crystalline silicon. A thin slice of semiconductor material is called a wafer in the electronic jargon. A typical wafer is made of extremely pure silicon, which using the G-cross-K process is grown into monocrystalline cylindrical ingots up to a diameter of 300 mm, which is slightly less than 12 inch. These ingots are then sliced and polished into wafers about 0.75 mm thick to obtain a very regular plate surface. When the wafers are prepared, it takes a number of process steps to create the desired integrated semiconductor circuit. The first semiconductor wafer was developed in the US in 1960, which the diameter of the semiconductor wafer was 1 inch. No matter what the semiconductor consists of, the wafer must be thick enough to bear its own weight so it does not break during the process of handling.
The problem statement for this project is: first, inspection of sample wafer. Sample wafers are inspected at a number of points along the process using inspection equipment and fault images that are reviewed by technicians. Second, ability of semiconductor wafer in development. The reformulation of semiconductor wafer of the issue is necessary for an imaginative approach. Third, saving for wafer production. Greater wafer area needs more capital expenditure in factory machinery, and the output performance does not decrease with the same yield. Fourth, production process of wafer making. The flow from silicon wafer fabrication to electronic product completion. Fifth, key interpretation and basic defects. The data are captured as a command of several sentences along with basic defect data automatically fed into a database. Lastly, semiconductor wafer in daily life. All sorts of technical developments have allowed the evolutionary production of electronic devices which have contributed enormously.
Next, we go to the steps of semiconductor wafer production process. Step 1. Creating the wafer. Creating the wafer. A wafer, also called a disc, is a thin glossy slice of a silicon rod that is cut using specific diameters. Most wafers are made of silicons extracted from sand. Once silicon is extracted from sand, it needs to be purified before it can be put to use. First, it is heated until it melts into a high purity liquid, then solidified into a silicon rod. Then slowly pulled into rotation as the liquid grows into a cylindrical ingot. This is why the finished wafer are all round this. Before it is completely cool, the cone-shaped ends of the ingot are cut off while the body is sliced into thin wafers of uniform thickness with sharp diameters saw blade. Step 2. The oxidation process. The oxidation process. process in which a thin layer composed by various materials is deposited. The technique forces oxygen or vapor to diffuse into the water surface at high temperatures between 800 and 1200 degrees Celsius so that a thin, smooth layer of silicon dioxide can be created. This layer protects the surface from chemical impurities and pollutants that permeate during the process. The silicon dioxide layer doubles as a trustworthy guardian against unintended adulteration during the ion implementation stage and as an insulator that separates each part of the electrical circuit on the water wafer to prevent a short circuit. Step 3. The integrated circuit. The integrated circuit. Numerous transistors, diodes, resistors, and capacitors are part of an integrated circuit and are connected to each other seamlessly. These components respectively play different roles in processing and storing electric signals. Transistors serve a power switch, and capacitors store energy electrically in an electric field, just like a warehouse. Resistors control the current flow to other components, while diodes manage the direction of that flow. To fabricate an integrated circuit, a very minute and complex pattern on which all the circuits are designed is transferred onto multiple layers of material. The transferring process utilizes photomasks that capture the miniaturized version of this pattern, just like film used for photographic printing. Step 4. Drawing structure in nanoscale. Drawing structure in nanoscale. The first step is to use computer-aided design CAD software and devise the circuit to be drawn on the wafer. Before this is carried out, an engineer actually steps onto the blown-up version of drawing to examine whether each part of the circuit is properly designed. After examination, the pattern design is duplicated onto a glass substrate made of ultra-pure quartz with a beam of electrons, also known as an E-beam. Step 5. Etching a circuit pattern. Etching a circuit pattern. Etching process in semiconductor fabrication use a liquid or gas etchant to selectively remove unnecessary parts until the desired circuit pattern are left on the wafer surface. By repeating this process on multiple layers, a semiconductor chip is eventually born. Two fundamental types of etchants are liquid phase, we call as wet, and plasma phase, we call as dry. And the method used depends on which material is to be etched. Compared to the wet etching technique, dry etching is more costly and complicated. However, with continued innovation in semiconductor technology and the circuitry now in nanoscale, dry etching is the more widely used technique as it produces a higher yield. Step 6. The addition electrical property. The addition electrical property. The thin film fabricated through the deposition process can be categorized into metal conducting layer for electrical connection between circuits and dielectrical insulating layer that electrically isolated the internal layer or protect them from contaminants. For semiconductors to develop electric properties, a process of implanting ion on the deposited layer must be followed. Ion implantation is the process of implanting electrically charged particle onto a semiconductor surface with circuit pattern. These ions are referred to as impurities and include boron B, phosphorus B, and arsenic As. By inserting impurities into the water surface in the form of fine gas particle to a desired depth, The silicon water acquired its electrical conductivity. Step 7. The material interconnection. The metal interconnection. Number 1. Achievements to the semiconductor substrate wafer. The metal needs to be easily and strongly adhere to the semiconductor substrate in thin film to form. Number 2. Low electric resistance. Since the metal circuit delivers the electric current, the substance must have low electric resistance. Number 3. Thermal and chemical stability. It is important that the attribute of the metal do not change during the metal interconnection process. Number 4. Easy information of patterns. Regardless of the quality of the metal, it is essential that the material can easily form pattern, especially during the etching process. Number 5. High reliability. The advancement of integrated circuit technology, the metal interconnection material needs to be durable even in minute scale. Number 6. Manufacturing cost. Even if the above conditions are met, the cost also has to be suitable for the mass production of semiconductor. Step 8. Electrical die sorting. Electrical die sorting. There are several of steps of die sorting electrical test and WBI wafer burn-in. Number 2. Pre-laser to determine hole or cold. Number 3. Laser repair and post-laser. Number 4. Tap laminate and back grinding. Number 5. Inking. Step 9. Packaging and packet testing. Packaging and packet testing. Semiconductor packaging serve a variety of purpose, ensuring the interterminal connection, supplying electricity, and providing heat resistance and protection for the IC. The packaging also ensures protection from external factors, including humidity, chemicals, impact, and vibration. The semiconductor chips are put in a device where they are tested under various conditions of voltage, electrical design, and temperature. In doing so, we can measure their electrical and functional characteristics as well as their performance to detect any defect.
Discussion. Semiconductor wafer have two types, which is undoped semiconductor and doped semiconductor. Undoped semiconductor is also known as intrinsic semiconductor wafer. It is made from pure crystalline of silicon or any other semiconductor material. Doped semiconductor is not 100% silicon or pure semiconductor material. In dope process, the semiconductor wafer are divided into two types, which is N-type and P-type semiconductor. In N-type, atoms of phosphorus, arsenic, or antimony are added. It is enriched from negative charge ion or electron. P-type semiconductor wafer, atoms of boron are added. It is enriched with positive charge hole. Semiconductor wafer can be categorized into two by dopant level. It is extrinsic semiconductor, which have tiny to moderate percent of the dopant, and degenerate semiconductor, which have high percent of the dopant. There are reasons why wafer are round. First, it is because it more stable. Second, straightening the round of silicon causes additional stress. Last, much easier when doing homogeneous process during microchip manufacturing, which is CPM, etching, and spin-on.
The conclusion for our presentation is silicon has proven to be a stable option in producing semiconductor wafers. Although other conductors are employed in more specific applications, silicon is the best and most used semiconductor. This is because its electrical current can pass much faster than other conductors via the silicon conductors. Silicon wafer production is an extremely important part of developing and extending a wide range of technical advances. Lastly, some precaution must be taken while handling the process of semiconductor wafer production to protect the actual semiconductor products from coming into contact with dirt, hair, flecks of skin, and other contaminants that can be shed from human bodies. That's all for our presentation. Thank you.